Hello friends, this video on hydrocarbons part 22 is brought to you by examfear.com. No more fear from exam. Now we'll talk about the chemical properties. We see alkynes, they have rich source of pi electrons, right? So they easily go addition reaction. Most of them are electrophilic addition reactions. Similar in case of alkenes, since we have electrons here, so there are pi electrons here. So the electrophiles, the one which loves electron, can easily attract this guy. And since they are triple bonds, you can break it to form double bond and single bond. So they generally go for electrophilic addition reaction, but in some cases they also go for free radical reactions. Right? They also undergo nucleophilic addition reaction under presence of heavy metal ions. And alkynes are very weak acids. We'll talk about the acidic behavior of alkynes. They react with strong base like NaNH2. They are very strong, very weak acid. Please note this. We'll discuss about this. So we'll talk about the acidic behavior. This guy is more acidic and this guy is less. This guy is the maximum acidic. So let's discuss why it is acidic. If you see in acidic, only the terminal hydrogen is in alkynes are acidic. Right? And why it is terminal only? The terminal alkynes are acidic. Why? Because if you see this guy, it develops, this is sp hybridized. If you see this guy, this is sp hybridized. This is also sp. And this is sp3. Since sp is more electronegative, this carbon will get negative charge. So if you see this guy now, since this carbon will get negative charge, this guy will get slightly positive charge, right? Since it will get positive charge, it can come out easily, so it can lose this H plus easily. But please note that even we are saying it is acidic, these guys are far less acidic than water. So water is more acidic than all these. Correct? Please note that even if we are saying it's acidic, but these are less acidic than water. So this is the trend we have because of the sp hybridization. This gets negative charge, and here if you see, I'm saying the terminal alkynes are more acidic. So in this case, this alkyne is not terminal, right? So this has no hydrogen to lose. So this will get a negative charge. This also gets slightly negative charge, but this will be difficult to pull out. But in this case, it's a terminal carbon, so the negative charge, this can easily come out. Correct? So the terminal alkyne is acidic. So we'll talk about the reactions. We'll talk about acid-base reaction. We'll talk about addition reaction. In addition, we'll talk about addition of dihydrogen, halogens, hydrogen halides, hypochlorous acid, water, HCN, CH3OH, and acetic acid. Because we told that this is generally electrophilic addition. If you see, most of them are electrophilic addition. And then we'll talk about the oxidation reaction. We'll talk about combustion, controlled reaction with oxygen, and ozonolysis. And we'll talk about polymerization. We'll talk about cyclic polymerization and linear polymerization. So let's talk about acid-base reaction. So as I told, these alkynes are acidic in nature, right? So it reacts with sodium metal and soda amides because they are strong base, and they react. These guys react with ethyne to form sodium acetylide, and it liberates hydrogen gas. And these reactions are not observed in case of ethene and ethane. So you can say that this is acidic. Ethane is acidic, right? So the terminal atoms in the ethyne molecules have highest electronegativity. I have discussed why, because they are all sp hybridized. Since they are sp hybridized, this carbon is more electronegative. For example, if you see this reaction, this ethyne will react with sodium, it will becomes this guy Hc, C minus A, N plus N half H2. This is sodium acetylide. One more reaction. The same guy, what you have got, again it will react with sodium, it will replace the other hydrogen, because both these terminal hydrogens are acidic. Correct? So it will get this product. can take this example also. This will react again with sodium, so this will go off, so it will become this product. Again, if you add here sodium, it won't have any reaction because it won't be able to pull this hydrogen. Correct? Only terminal hydrogens are acidic. We'll talk about addition of hydrogen. So the first one is you can add hydrogens on the same nickel catalyst. We have taken these examples so many times where you have this nickel catalyst and then you can add hydrogen in that. So this is the typical reaction. I can explain you once again. This is a metal surface. The moment I add hydrogen, the hydrogen bond breaks and you get this hydrogen metal and this bond. And then when you add this ethyne here, so what happens is this bond is weakened and then this attacks here, and then you get something like this, right? And again you do the same thing. You take hydrogen, this is the platinum plate, you put some hydrogens here, then hydrogen bond will break and you'll have this hydrogen and metal bond, something like this. This will go off, this will go off, and then this double bond will also break and you'll get CH3 and CH3. So you have seen this kind of reaction in the past two slides. So if you have doubts, you can see the reactions of reactions of the hydrogen in the presence of nickel and platinum catalyst, the Alkynes reactions. Same thing here, you have this guy, you add hydrogen, this triple bond will go off, it will become double bond. You add more hydrogen, this will also go off and become single bond. We'll talk about now addition of halogens, right? This is called halogenation. So this is my propine. I'm adding bromine to it, I'm getting this guy. Again, adding more bromine, I'm getting this guy. So we can see the reaction mechanism of seeing these. We have seen almost similar to this. The triple bond. I have a bromine here, right? These are my 6 electrons. This is attacked by this guy. This bond breaks, right? This bond breaks. It gets a negative charge, and this guy is attacked here. So what you get here is the double bond here. I'll get a bromine here with a positive charge and a Br minus. This Br minus will attack this carbon here. So what you get is something like this. You repeat the same process again. You repeat the same process. You have Br, right? This guy will attack here. This bond breaks, and this guy you see will attach to this carbon, right? So again the same thing will happen, and you will finally get this guy. Let's talk about addition of hydrogen halides. We follow the Markovnikov rule, and if you see there's a triple bond, this will be attacked by HBr, will form H plus Br minus ion. This H plus will attack this guy, right? And then if you see the intermediate cation will be formed at double bond, and you'll have one positive charge here. Then you have CH2 and H here, let's suppose. Correct? And then on this you'll attack Br minus here now. So you'll get CH Br double bond CH2. Correct. Now again, when you react this guy with H plus Br minus, again the same thing will happen. This guy will attack this guy, right? This double bond will attack this H plus, and then you will form here CHBr2 and CH2 plus, and again this bromine will attack this guy. You will get CHBr2 and CH3, and that is my answer. So this is how you do the addition of. So in this case, since it was only 2 carbon, so even if you do in the presence or absence of peroxide, it will be all same. But if you have something like this, CH, right? So in that case, in the presence of, in the absence of what you call peroxide, what will happen is we'll follow the Markovnikov rule, and the bromine will get added here. Correct, will be CH3, C, Br, Br and CH3. And in the case of presence of peroxide, we have told you we'll get this Br free radical. We have discussed this in case of alkanes actually, and then this Br free radical will form anti-Marconi product, that is CH3, CH2, CH, Br. This will be the presence of peroxide. So when you talk about the reaction of HBr, addition of HBr at least, you should know both presence and absence of peroxide. It's a very important reaction actually. Now we'll talk about addition of hypochlorous acid. So hypochlorous acid is what? HOCl, right? This is an electrophilic addition again. So I have, let's suppose, this CH triple bond CH, I add HOCl. What I get is this will break into OH minus and Cl plus. So this will become Cl, CH double bond CH, OH, right? Because this will break, right? OH minus and Cl plus. So this bond will break, 1 minus 1 plus, and this will be added. So again, if you add HOCl, so this will be again CH and Cl. Here more Cl will be added, and here one more OH will be added. This should get, but this guy is unstable. Correct? So what will happen is this guy will lose water from here. Water from here. So it will form CH, Cl, Cl, COH and water. This is called dichloroacetal. This is addition of hypochlorous acid. Pretty simple. So this is pretty simple. This will be OH minus and Cl plus. So here when chlorine will get added, and here this guy will be added, because this guy itself will attack. Now we'll see addition of water. But we have told that alkynes, they don't mix with water, right? Because they are alkynes are non-polar, water is polar. But how will they react? You are correct. They don't mix with water at the lower temperature. But when you increase the temperature and you use a proper catalyst, for example, mercury sulfate and dilute sulfuric acid at a high temperature, it forms carbonyl compound CH3COH. So if you don't put this mercury sulfate, the reaction will happen, but it will be very, very slow. It's very, very slow, right? So if you put this, the reaction is fast. It's a nucleophilic addition reaction because it is H plus. The first thing that will happen is this triple bond will attack this H plus. So let's see what compound gets formed. You get in this case CH plus and double bond CH2. This is what you get. And then what you get, you have this water here. So you just add this OH minus here. Correct? So what you get is CH2 OH double bond CH2. Again you do the same reaction. You add with H plus, the H plus here. It's react here. So you get again CH plus, you get OH and CH2. And with this, I have so many OH minus in this whole solution. Will react here. So you will form CHOH, OH and CH3. But now what will happen is it will tautomerize actually. So this H2O, it will lose this water. So it will get CH3COH and water molecule. So this is my correct. Or directly from this step also, if you see, from this step also you can actually do the isomerization. This also it can do the isomerization. So this bond, it will break actually. So the bond will break and this H will come. So you can do either of these. You can just react it once again, you will get the same product, or you can From here you can do the isomerization. Now let's understand the reaction of alkyne with HCN. So HCN adds on ethyne in the presence of BaCN2 to form vinyl cyanides, also called acrylonitrile. So if you see the reaction, I have my ethyne here. You add HCN to it in the presence of BaCN2, right? What you get is this guy, CH2 double bond CH, CN, and this is nothing but acrylonitrile. Correct? It's HCN actually. And this is also a nucleophilic addition reaction. Nucleophilic addition reaction, because this will be H plus and Cn minus. If you want to see the reaction mechanism, I'll show you. So this guy, H plus Cn minus, H plus will be here. So this will attack actually. This is a nucleophile, loves. Sorry, Cn minus will attack first, right? So you get something like this. This is a nucleophilic addition reaction here. So Cn minus will attack first, right? CH, it will form CH double bond, CH and Cn. Correct? And here it will get a negative charge. So on this my H plus will attack. So you will get CH2 double bond, CH and Cn. This is my acrylonitrile. Correct? So this is used to manufacture polymers or something like that. The nucleophilic addition reaction. Please note, other reactions which we have learned was electrophilic. This is a nucleophilic addition reaction. The next is the addition of CH3OH. So you can add CH3OH on ethyne, but you have to do in the presence of potassium methoxide. So you get methyl vinyl ether. So I'll show you the reaction. You have this ethyne, you have to add CH3OH in the presence of potassium methoxide, that is K plus OCH3 minus, right? And you'll get CH2 double bond CH OCH3. It's nothing but methyl vinyl ether. Methyl vinyl ether. Correct. Now let's understand addition of acetic acid. Let's talk about addition of acetic acid. So in this case, we add 2 molecules of acetic acid to my triple bond. Example, I have ethyne here. So here I have to add 2 molecules of acetic acid, and you have to do this in the presence of BaCH3CO2. So with this, what you get is CH3, CH, OCOCH3 and OCOCH3. And this further, when you heat it, it gives some other product. First let me give you the whole mechanism. When you heat this, you get in this case this guy, CH3, COH, this guy, right, and this whole guy, that is CH3, COO, this guy, then I have oxygen here, then I have COO, CH3. Okay, this is ethanol here, and this is ethanoic anhydride. I'll show you how it happens. So if you see, I have a triple bond, right? I have CH3COH acetic acid. I can write this guy as CH3CO minus and H plus, and I have triple bond. See, triple bond will attack this hydrogen, correct? So it will form C double bond CH, and we'll get a minus. I get a plus here, right? A plus charge here. So on this guy will attack. So with this, I get what? I get CH double bond, and this C I got this guy O CO, CH3. Correct. Now again same thing will happen. Now we'll add one more H plus here. So this guy will again attack this guy. So it will form CH2 single bond. It's a plus sign here, and I get O, CO, CH3. Now since I had H plus here, this guy is empty here. My CH3 CO minus is free here. This guy will get attached to here. What you get is CH2 single bond CO, whatever was here, and this guy, that is O, CO, CH3. This is same as this. And now when you heat it, it will break actually. It will break into this part is one part, and this whole part is another part. And that's what you get. Correct. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.